Hi, everyone. Here, we're going to continue on the Lab 2 operations. So now we want to join all the data into a single main data frame. We already did a small join over here for the county data that we aggregate into a state poverty data frame. But now we want to join all the other stuff we have: population, information, taxes, and GDP. So first, I'm beginning with the state poverty data here. So joining state poverty data with the state codes. Okay, so the state poverty is the one that we had just created here before. And notice that state poverty data frame has 51 rows, whereas state codes has 55, because state codes has some extra ones for the US territories and stuff. So I'm going to create the variable. It's going to be called, the data frame is going to be called state poverty codes equals PD merge. Same merge as we did before. State poverty on the left, so this gained primacy, and whatever matches from the right, because this is a left join, whatever matches from this state codes will get included, and whatever doesn't, it will just disappear. So once again, because this is a left join, and this state poverty is on the left and has 51 rows, then we should end with a data frame that also has 51 rows. The extra 5 rows that was in state codes will not get merged, will not get matched, because there's nothing, they don't exist on the state poverty data frame. So that's because we're doing a left join. If we do a right join, then the state codes would get primacy, and we should have the final one, the merged one, would have 55 rows. And notice we need to have a field to merge them on, and they have to have the same name in each of the data frames. And we kind of did the operations before, so both of them have postal, and we use postal, and after you run, you see now your data frame is expanding. Now, before, we just noticed how we didn't have the state name in the state poverty data. Now we merged it with state codes, and we have the state names as well. You can check the length of the data frame. It does only have 51. So whatever extra was in state codes disappeared. Now we want to merge state, whatever we merged here, state poverty codes, I named it, with state taxes. Okay, we're going to continue with the left join on state poverty codes, because this is kind of our ongoing full main data frame that we're going to keep. So we're going to use that as the left. We're going to do a left join, but you also have to determine which column we're going to make the join on. It's not going to be postal for this one, because one of those doesn't have postal, but it has something else. So you figure it out what to do it, the join on. And then you print it out. You should see that it came up. Now I started realizing that a lot of stuff is accumulating that we don't need. Like we have so many state names, like state with a big S, state with little s, standard, and state underscore name. So you can use this function here to drop some of the columns that we're not going to need. That's how we do it. So you can take a look at that. You don't need to do that, but you can to clean up your data frame. And then we have one more, which is the, actually we have 2 more. We have the population data. So we're going to, once again, take this ongoing here. Just keep adding names to it: state poverty codes, taxes. So we're going to add here state poverty codes, taxes. We're going to merge that with population. And maybe we can start changing the name so it doesn't get too long to like full DF or main DF. Notice that I want to put this underscore here, or just like this. We can't have space in these variables like that. So add your code here, just like the previous ones for merging, and identify what has to be merged on, and you should have the correct merge. And you can always you have to do a sanity check, right? Go back to the initial data frame, see if the values are corresponding. Like California should have population of 39,538,000, and Arizona should have population of 7 million, and so on. You can check that online too, of course. For the taxes, might be a little bit tricky, but you could also always check on the original. I actually double checked when I did the poverty estimate. You can see that the poverty estimate is correct. So these are, once again, this is population. So this is 4,419,167, and they're all matching. So you are merging correctly. And then lastly, want to merge with GDP. Now the thing is, once you merge with GDP, if you follow everything as I have done, you're going to see that it doesn't merge well on the main merging variable. So if we go back to state GDP, what did we have? State GDP, we had state name. We had state, and then we fixed it, removed that asterisk, but we had just state name. We don't have postal. So we're gonna need to use that to merge it on. But we get some issues there, and it doesn't merge. And then there could be multiple reasons why a merge doesn't come through. So I actually wrote some of these down here. Index needs to be reset. Data types need to be the same for keys joined on. So sometimes one data type state name is string, but another, it's could be integer. In this case, it's not, because these are words, but so they're both strings. But another big one is hidden characters are not matching values correctly. So once we take a look more specifically at state GDP, I know the other ones, the ongoing full main data frame, were kind of merging correctly. So I'm assuming that everything was okay there. So something is wrong with the GDP, because everything merged correctly before, except now this GDP is giving problems. So I take a look more detail on the GDP, and if you just write it aloud like this and hit Shift Enter on the cell, it will print the whole column. And one thing that was odd was this District of Columbia here. Notice how it has like only one that has like going out like this. So I know I changed that earlier too, but it's a little bit weird that it's like that. And then if you add actually a new number, it will give you the specific value of each row. And then, so if you put 0, it'll give you the first one, like Vermont. If you give you 1, it's going to give you Wyoming, 2, Alaska. But notice there were some hidden characters there. It's not printing out here. There's some hidden characters related to the encoding and other just data types, transformations that the data does, because you're converting data from one Excel to a CSV and so on. So these things always happen. We got to look out for it. And so I'm going to ask you to remove those values from this data. Notice that you can't see it, but we know it's there, because if you look up the specific value, it does come up when you do it this way. So I'm going to ask you to for this data frame, state GDP, state name, you're going to go and replace these values. Now, there are different ways you can do it. If you run these for the 0 and the 1 and the 2 and the other ones, you see that they're the same. So we have this string of characters and this string of characters that we need to remove. And you can do this 1 or 2 operations, but no more than 2 operations. An operation would be like a line of code like this. So this is 1 operation only. So if you have multiple lines, then you're doing multiple operations. Don't do more than 2, but you can use regress, or you can use the literal replacing as we did above. And after you do that, you should match well. But another issue that may come up is that because we did have this joined here, it joined with the columns, but the columns didn't match. So all these are null values, non-available null values. And then when we did match it correctly, those were kept there as well in that main full data frame that I had. Okay, so what I did here is merge full data frame with the new modified state GDP into the full data frame again, using the same name to override it. But this was kept there. Now, there are different ways to remove this. I would remove it. That's a good thing for you to remove it. Notice you added an Y to the end of the names, because all the names already had been here, the column names. So it's kind of annoying to use this extra letter on the name, and it makes the data frame confusing. So you can go back in the join, maybe do the joining process again, or find a way to remove these extra useless columns here, and hopefully keep these names as the original ones without this underscore Y. And then I did add some little magic you can figure out how to do. And then you see we have the full data frame with poverty percent, median household income, postal code, and so on. Everything is in here. Some of these that look numeric are not numeric. I only modified some. So total tax is numeric, property tax is not numeric. It looks numeric, but it's not. So there's some other extraneous unnecessary columns here. You can drop, you can look up how to drop. There's some function how to drop above. So we can just keep the standard state name, but that's pretty good for now. So we can move on. Also notice that you might need to add some additional columns for calculations. And this is why we merged all the data together, and then we can use the pandas data framework to do calculations very simply. So for example, we have total taxes, but we know that the higher the total taxes, the higher the population. So if we have, for example, more people in poverty, we're also going to have higher total taxes because more people, more money, more taxes, more poverty. So we want to normalize some of these measurements. And you can do them very simply here by just kind of dividing. So for example, if we want to create taxes per GDP, per total GDP, which is a more normalized measure of taxes, you just do the data frame, total taxes, and then specific column, and then just there's the division symbol, and then total taxes divided by GDP 2020 millions. Those both have to be numeric, and then it creates a new one and puts it in here. And then if you print it out, you see it taxes per GDP. Remember, GDP is in millions, GDP in millions, so this means $24 per million taxes. You're dividing total taxes by GDP in millions. Now, other useful ones that you may need are going to be taxes per population, maybe also some other ones that might be useful, such as GDP per population, and so on, which follow the same framework. So most of the hard stuff was really there in this data wrangling, data cleaning, data processing part. And then for actually to apply the basic statistics is very simple. Once we have the data frame ready, we can use describe function, and the describe gives us all the important measures that we need: standard deviation, mean value, maximum value, quartiles, count of instances. Count, don't confuse count with sum. Count is not the same as sum. There's actually not a sum here, but there is mean. Mean of all the states. And also it only applies to those variables that are numeric. So it's kind of beautiful already and ready for us. Notice, for example, it doesn't give us the states associated with a particular value. So for example, if you want to know what are all the states that are above the 75 percentile for the poverty percent, which is at 15.149. So what you can do is you can do this operation to select only certain values of the data frame. And it might look a little bit weird at first, but you write the name of the data frame and then square brackets and then the data frame again with the particular field that you want to filter by, and then kind of inequality operation. So here's going to create a data frame where full DF poverty percent is greater than 15.149. And it actually prints out the whole thing if you do it this way. But actually, if you wanted to just change it just for the name, you could actually just write like that. Whoops. State name. And that would just print out just the name. So this is like one big data frame filtered. And of course, you can also, for example, if you want to look out exactly which one has this maximum value, well, you can look up max 91957, and that will give you that one state that has the maximum value, but this one was for median household income. So median household income. So like that, median household income equals, and equals is double equals for the test. Now, some of these numbers are rounded. So maybe it's not 91957, it's 91957, 956.999, and it got rounded. So you got to be careful with that and figure out how you can identify the specific ones that you need. And then lastly, the correlation also is super easy. Once you have the full data frame, you just apply the correlation function, and then it gives you the correlation matrix of all the numbers. And here are some of the ones I got. Maybe I made a mistake. I'm not sure if you're going to have the same exact numbers I'm getting here. Hope so. I think these are pretty good. But once you do that, then you can examine these. And these are actually fairly interesting. And you can examine the patterns. So for example, GDP and poverty, if you want to look at GDP and poverty. So GDP in 2020 millions and poverty percent. We assume that the higher the GDP, the higher the people, higher the poverty number of people in poverty estimate. And this correlation is very strong because more people, more money, higher GDP, but also more people in poverty. So we really want to look at poverty percent here. So we can see that the poverty percent in GDP is negative, but it's only slightly negative, 0.02. So the higher the GDP does not, it's a little bit less poverty, but this is probably not statistically significant because it's so small. So The higher the GDP, almost no correlation with the poverty percent. We would assume that higher GDP means less percent of people in poverty, but this does not show that. It shows otherwise. So this wraps up the instructions for this lab, and I hope this is useful to you, and I'll see you next time.